Hello, this is the Ham Radio Nomad. Thank you for coming and participating and watching the Amateur Extra Study session. Um, if you go down and look in the description, you will see a link to the playlist, and I will have the playlist also linked in the top right corner for those who are watching this afterwards. Um, for those that are watching currently, um, I have pinned the StreamYard link up top in the chat. You're welcome to click on it and join in StreamYard, and we will go through and ask the questions. So without further delay, let's get started. First question, what is an advantage of placing a grounded electrostatic shield around a small loop direction finding antenna? A, it eliminates unbalanced capacitive coupling to the surroundings, improving the nulls. B, it eliminates tracking errors caused by strong out-of-band signals. C, it adds capacitive loading, increasing the bandwidth of the antenna. D, it increases signal strength by providing a better match to the feed line. Hey, No Code Tech, just going through questions on the Amateur Extra Study session. And anyone who is watching, you are welcome to click the StreamYard link up top in the chat and join me, and we can go around and alternate reading the questions and answering them. I don't watch the chat for answers because of the delay between my video and YouTube. But if you do go through, a question, you're welcome to give hints of what would be good memory selections and explanations for questions. So, Gordon, this is the advanced. This is the top level, in the top level testing in the United States. It is very detailed and very advanced, very technical. And for this one, back to the question: what is the advantage of placing a grounded electrostatic shield? I'm going to say that it eliminates unbalanced capacitive coupling and improves nulls, and that would help with your direction finding. But yep, that is correct. What time of day can sporadic E propagation occur? A, only in hours of darkness. B, only around sunset. C, only around sunset and sunrise. D, anytime. Well, it is sporadic, so it can happen at any time. What is meant by blocking dynamic range of the blocking dynamic range of a receiver? A, the minimal difference in dB between two signals which produce third order intermodulation products greater than the noise floor. B, the minimal difference in dB between levels of two FM signals which will cause one signal to block the other. C, the difference in dB between the noise floor and the third order intercept point. D, the difference in dB between the noise floor and the level of an incoming signal that will cause 1 dB of gain compression? I don't have a clue. I'm just going to guess A. Nope. It is D. So one nice thing about hamstudy.org is they have explanations tied to each question. So dynamic blocking range, BDR, is the difference in dB between the noise floor and a off-channel signal that causes 1 dB of gain compression in the receiver. It is dynamic blocking range is the difference between the weakest signal that can be perceived and the strongest signal that can be presented without adversely affecting the weak signal. This adverse effect is about 1 dB attenuation, since this is the smallest change that can be heard by the human ear. Next question. What type of coordinate system is used by the Smith chart? A, resistive lines and reactance chords. B, voltage lines and current chords. C, voltage circles and current arcs. Resistance circles and reactant arcs. So Smith charts deals with resistance and reactance. And so it's going to be either A or D. And I don't know an easy way to remember. And if you've seen Smith chart, it has a bunch of circles and curves on it. So that's why I'll go with D. If anyone else has a better explanation, please add it to the chat or add it to the comments below, because that would be a good. What are some things to help remember some of these answers? Which of the following is a type of analog to digital conversion? A, level shifting. B, successive approximation. C, phase reversal. D, harmonic regeneration. And all analog to digital conversion, whether it be with radio waves or whether it be like with photos, is an approximation. So I'm going to go with B, successive approximation. Why might a DX station state that they are listening on another frequency? A, all these choices are correct. B, to separate the calling station from the DX station. C, to improve operating efficiency by reducing interference. D, because DX station may be transmitting in a frequency that is prohibited to some responding stations. And that would be A. All of those reasons are correct of why a station might be listening on another frequency. Which characteristics of a PIN diode makes it useful as an RF switch? A, low junction capacitance. B, reverse bias control. Reverse bias controls its forward voltage drop. C, ability to dissipate large amounts of power. D, extremely high reversal breakdown voltage. Diodes aren't known for dissipating power. That's what resistors do. And I'm pretty sure it's D, extremely high reverse breakdown voltage. Diodes are one way, so they can handle they can handle a large amount of voltage the opposite way without breaking. Is my guess, and I am wrong. So let's go with the second one that it was close. Is low junction capacitance. Okay. A PIN diode is a diode with a wide undoped intrinsic semiconductor region between the P and the N-type region. They say test hint, the PIN has 3 letters, answer, and the answer has 3 words. Okay, and so a wide intrinsic region makes a PIN diode inferior as a rectifier. Okay, and that's a rectifier is what I talked about with answer D. So it's because that's a typical function of a diode. So it is specifically a PIN diode doesn't have that high reversal, but it makes a PIN diode suitable for attenuators, fast switches, photodetectors, and high voltage power electronics applications because it has a low junction capacitance. What is the impedance 5 minus J25 represent? A, 25 ohms resistance in series with 50 ohms capacitance. B, 50 ohms capacitance in series with 25 ohms capacitive reactance. C, 25 ohms resistance in series with 50 ohms inductive reactance. D, 50 ohms resistance in series with 25 ohms inductive reactance. So J represents imaginary number. So the 50 ohms, the 50 is standard, which is resistance. So it's B or D. And the negative, now I have to remember this from last week when we saw this before. The negative is, one of them is capacitive and one of them is inductive. And I'm going to guess that negative means inductive, but I could be wrong. It could be negative, could mean capacitive, but let's see. It's either B or D. And I was wrong. So if it's a negative J or a negative imaginary number, it's capacitive. If it's a positive J, it's inductive. Hey, Andy. Okay. Thanks, NoCo Tech. I will update that once I get done. Um, what type of polarization is best for ground wave propagation? A, elliptical, B, vertical, C, horizontal, D, circular. And ground wave, I believe, is what talking about with VHF. So I'm going to go with vertical. Yep. Ground wave is it's going along the ground, which like vertical line of sight. So that's VHF, UHF. If it's bounces off the, if it's reflected off the ionosphere, it becomes elliptical, and therefore it can work with both vertical and horizontal polarized antennas. What is the phase relationship between the current through and the current and the voltage across a series resonant circuit at resonance? A, the current leads the voltage by 90 degrees. B, voltage leads current by 90 degrees. C, voltage and current are in phase. D, voltage and current are 90 degrees out of phase. I think I've seen this one before, but I don't remember it. So I'm going to guess current leads voltage by 90 degrees. Nope. So at resonance, the voltage and current are in phase. When the circuit is in resonance, the inductive reactant and the capacitive reactant are equal, so they effectively cancel each other out with resulting 0 degree phase angle. Thus, in turn, makes the circuit resistive with the voltage and current in phase. How many times per second is a new frame transmitted in FastScan NTSC television system? I think most TV is either 30 or 60. I'm going to go 30. Yep. Each frame consists of 2 fields, and fields are transmitted at 60 times per second. So that's entire frame over 30 times a second. What impedance does a half-wave transmission line present to a generator when the line is shorted at the far end? A, very low impedance. B, same as output impedance of the generator. D, the same as the characteristics impedance of the line. Very high impedance. I'm going to go with very high impedance, and I'm wrong. It is very low impedance. At a half wavelength, the end of the transmission line matches the amplitude of the input to the transmission line when a standing wave exists. As such, shorting it will take energy out of the standing wave and be seen as a short at the generator, which is seen as a low impedance to current flow when voltage is applied. Contrast this to a quarter wave long transmission line where the peak amplitude of the standing wave at the generator will correspond to the node at the end of the transmission line. If we don't terminate the endpoint in this case, the reflected wave will be 180 degrees out of phase at all points. And at all points, the generator will have to work against itself to cancel its own reflections. What is meant by the blocking dynamic range of a receiver? And we've had this one before, is D. What impedance? Okay, we just read about this in the explanation for the previous answer. What impedance does 1/4 wave transmission line present to a generator when the line is open on the far end? So if it was closed at the far end, we just read that it would be very high impedance. Oh, I'm going to say same as the characteristics of the impedance line. I don't know if that's correct or not, but I'm going to guess that. Nope. It's also very, so if it's a quarter wave and it's open, it's very low impedance. If it's a half wave and shorted, it's very low impedance. The lengths of of a transmission line can be used to transform an impedance. Think in terms of Smith chart. One complete revolution will around the Smith chart is half wavelength. That is half wavelength and multiples thereof. A transmission line will leave the impedance seen at the generator unchanged. This also means that a quarter wavelength of the transmission line rotates the impedance 180 degrees. Since an open circuit is located on the edge of the Smith chart at one end of the resistance axis, 180-degree rotation moves it to the opposite end of the resistance axis, the short circuit. So the generator sees a very low impedance when an open is transformed by a quarter wavelength transmission line. Which, if you think of it, that's basically what a dipole is. A dipole is two lines, quarter wavelength in opposite directions that are open. What type of satellite appears to stay in one position in the sky? And I'm just going to jump right to D, geostationary. Geo, Earth, and it's stationary. What is meant by the term mode as applied to an amateur radio satellite? A, the satellite's orientation with respect to Earth. B, the satellite's uplink and downlink frequency bands. C, whether the satellite is in low Earth or geostationary orbit. D, whether the satellite is in polar or equatorial orbit. I'm going to guess B, the satellite's uplink and downlink frequency bands. That is correct. All these others talk about characteristics of the satellite, but they don't. Only B is talks about the actual amateur radio part of it. And we've had this one already. And we had this one as well. What is a resonant frequency of a RL circuit if R is 22 ohms and L is 50 microhenries and C is 40 picofarads? I don't have a clue. I'm just going to guess B. And I was right. By a very lucky guess. And here's a here is a bunch of equations. So it's the square root of the capacitor times the square root of the capacitive and the inductive, and then multiply that by 2 pi, and then you take the inverse of that. And yeah. That's a pretty complicated equation to remember. So, yeah. I don't know. Either hard memorization of 50 microhenries and 40 picofarads is the one that's in the 80 meter band. Yeah, that's cheating way, which doesn't really, you could say 50 plus 40 equals 90, and 80 meters is the closest to 90. I don't know. I don't know if that is a way of memorizing it or not. What is a phase relationship between the current through and the voltage across a series at residence? At residence, they are in phase. And we had another one we've had already. Which of the following HF digital modes can be used to transfer binary files? Hell, I have no idea how to pronounce that. Amtor, RIDI, or Pactor? I'm going to guess Pactor, but I'm not sure. Yep, it's Pactor. Which of the following taps in a digital signal? What is a function of taps in the digital signal processing filter? A. Provide incremental signal delays for filter algorithms. B. Select the point at which baseband signals are generated. C. To reduce excessive signal pressure levels. D. To provide access for debugging software. I'm going to go with B. Nope. Is A. Provide incremental signal delays for filter algorithms. Hint, both question and answer have the word filter in them. So yeah, that's a thing that I've noticed, that a lot of the hints are look for words that are common both between the answer and the question. Another one we've seen already. Another one we've seen. Which of the following components can be used to reduce thermal drift in crystal isolators? NPO capacitors, B. Toroidal inductors, C. Wire wound resistors, D. Non-inductive resistors. I'm going to go with A. NPO capacitors. That is correct. NPO stands for negative positive O, meaning that for negative or positive shifts in temperature, the capacitive changes 0 parts per million, meaning it has a flat response across a wide range of temperatures. What S parameter represents input port return loss or reflective coefficient equivalent to VWSR? S22, S12, S11, S21. And another one I don't have a clue on. I'm just going to guess at S21. Nope. It is S11. The two port S voltage parameters for a linear electrical network are defined as S11, the input reflection coefficient, S12, the reverse gain, S21, the forward gain, S22, the output reflection coefficient. What is the approximate physical length of a solid polyethylene dielectric coaxial transmission line that is electrically 1/4 wavelength long at 14.1 megahertz? 14.1 megahertz is in the 20-meter band. So a quarter wavelength of 20 meters is going to be about 5 meters. And okay, it's on the very low end of. Oh, that's okay. The the thing that I did not take into account is you need to deal with the velocity factor. So the velocity factor of solid polyethylene dielectric coax is 2/3. So you have to then, so a quarter wavelength of 20 meters is 5, but then you need to take 2/3 of it, which will then comes to 3.5. So it's a trick question. Which of the following types of communications may be transmitted to an amateur station in foreign countries? A. Communications incidental to the purpose of amateur service and remarks of a personal nature. B. Related messages for nonprofit organizations. C. All these answers are correct. D. Messages intended for users of maritime satellite service. And this one is A. Communication incidental to the purpose of amateur service and remarks of personal nature. So this is an example of a question that is carried over from the technician and the general. What action or action should you take if your digital message forwarding station inadvertently forwards a communication that violates FCC rules? Notify originating station that the communication does not comply with FCC rules. B, all these choices are correct. C, discontinue forwarding the communication as soon as you become aware of it. Notify the nearest FCC field engineering's office. And I'm going to go with D, discontinue forwarding the communication as soon as you're aware of it. What logical operation does an OR gate perform? It produces a logical it produces a logical 1 at its output if any or all inputs are logically 1. And that is the answer, so I'm not going to continue on. But yeah, that's similar to logic in math. One or any or all inputs are 1, then the output is going to be 1. What may be the penalty for and just a moment, I am getting a phone call in for some reason. Okay, so back to our normally scheduled broadcasting. What may be the penalty for a VE who fraudulently administers or certifies an examination? A sentence up to a year in prison. B, all these choices are correct. C, a fine of up to $1,000 per occurrence. D, revocation of the VE's amateur station license grant and the suspicion of the VE's amateur operating license grant. I don't know. I'm going to guess all these choices are correct. Nope. So it's only D, revocation of the amateur station license grant and operating suspension of operating license grant. What type of antenna pattern is shown in figure 39-2? A, radiation resistance. B, polarization. C, azimuth. D, elevation. I'm going to go with A, radiation resistance. Nope. It is elevation. Notice the type of reference of the propagation is a semicircle as looking from the side. Transposing the notion that the antenna is positioned in the middle and projecting outward. The numbers along the outer radius depict the various degrees of azimuth that the signal is projected. We can visualize the various strengths of these at various degrees. For example, the maximum lobe of this pattern is about 0 dB at approximately 47.5 degrees of elevation. Okay, so that's what it's asking for, is what is the degrees, or what do the degrees represent? And it's the elevation over the ground, from horizon, yeah, from the horizon. Who does Part 97 task with maintaining the pools of questions for all U.S. amateur license examinations? And that is the VECs. What is the function of TAPS? And we got that one already. What type of regulations does the PRB1 apply? A, state and local zoning. B, use of wireless devices in vehicles. C, FAA tower height limits. D, homeowners associations. I don't know. I'm going to guess FAA tower height limits. Nope. State and local zoning is what PRB-1 apply. What describes the orthogonal, and I'm slaughtering that pronunciation, frequency division multiplexing? A digital mode for narrow band, slow speed transmissions. B, digital modulation technique used using subcarriers at frequencies chosen to avoid intersymbol interference. C, a frequency modulation technique that uses non-harmonical related frequencies. D, a bandwidth compression technique using Fourier transforms. I'm going to go with C, and I'm wrong. It is B, a digital modulation technique using subcarriers at frequencies chosen to avoid inter-symbol interference. And the explanation just basically reiterates what the answer is. So not much help there. When scheduling EME contacts, which of these conditions will generally result in the least path loss? A, when the moon is at apogee. B, when the moon is full. C, when the maximum usable frequency is above 30 megahertz. D, when the moon is at perigee. And I guessed D, when the moon is at perigee. So apogee and perigee are the points at the that it's at the minimum and maximum distance from the Earth. Perigee is at the minimum, and apogee is when the moon is the furthest from the Earth. So when the moon is the closest, there's going to be the least amount of loss. What is programmable logic device? PLD. A logic circuit that can be modified during use. A programmable collection of logic gates and circuits in a single integrated circuit. C, a programmable equipment used for testing digital logic integrated circuits. D, a type of transistor whose gain can be changed by digital logic circuits. And I believe it's going to be B. Yep. It's a single integrated circuit that can be programmed. What type of, and we had that one already. So I'm going to have this be the last one. We have Ham Radio 2.0 is doing a live broadcast in about 10 minutes. So I'm going to do this question and then wrap up and send you guys over to watch his live stream. Which of the following describes a G5RV antenna? A wideband dipole using shortened coax cable for radiating elements and fed with a 4-to-1 balun. B, a multi-band trap antenna. C, a multi-band dipole antenna fed with coax and Balian through a selected length of open wire transmission line. D, a phased array antenna consisting of multiple loops. I'm going to go with B, and I'm wrong. A G5RV is a multi-band dipole antenna fed with coax and a Balian through a selected length of open wire transmission line. So thank you for all those who were watching today. And I will be doing this again next week. Same time, 6 o'clock Central. And I will also be doing a live stream on Tuesday night. I haven't decided what time yet, but I will post it probably either tomorrow night or Tuesday morning. And then I will also be doing a live stream FT8 practice session 4 o'clock Central on Thursday before Thursday night ham radio. So thank you all for watching. I am just posted the link to Ham Radio 2.0's station. So go over and watch his live broadcast, and he is interviewing the people from Last Man Standing's event, HF event. Welcome, Aaron. Thank you for joining me. I'm just wrapping up now and gonna have you guys go over and watch Ham Radio 2.0, and I believe probably Frank is going to be on there too. Go watch his stream, and hope you all have a wonderful evening, and 73 until we talk again. Thank you.